The force of attraction F between two bodies varies directly as the product of their masses m1 and m2 and inversely as the square of the distance d between them. When we are given that the force is 20 newtons when m1 is 25 kilogram, m2 is 10 kilogram, and the distance is 5 meters. We have to find an expression for F in terms of m1, m2, and d. Now, this is a pictorial view of what we are being told, that two bodies m1 and m2 separated at a distance d, and they have a force of attraction F between them. Now, we are told that F varies directly as a product of their masses, the product of their masses. That will be m1 multiplied by m2, that's m1, m2, okay? And inversely. Now, because they said and inversely, that means the product is there. Inversely will be 1 over, okay? So that will be over the square of the distance d between them. That's the square. That will be raised to power 2, okay? So we have inversely as d raised to power 2. Now, this is a classical question in variation, okay? And we're just going to use the principle of variation to solve this question and get our answer out as we have been asked. Like, for example, in the first case, we are asked to find the expression for F in terms of m1, m2, and d. But looking at this, we are only seeing a sign of proportionality. For us to make it an equation, we need to introduce the constant of proportionality. So that constant here, I want to use k. So I can now say F is equal to, now I'm not going to say is varying again because I'm introducing the constant of proportionality. So F is equal to k multiplied by m1 and m2 over d raised to power 2. But I've been given a case scenario that the force F, when it is 20 newtons, the mass m1 is 25 kilogram, okay? Then m2 is 10 kilograms, and the distance between the two bodies is 5 meters. So all of this, we are just going to substitute into the expression that we have for F so that we can find the value of the constant k. So if you do that, F is 20, we have k, m1 is 25 multiplied by m2, that is 10, divided by d, that's 5 meters. That's 5 raised to power 2, yes, 5 raised to power 2. 5 raised to power 2 is 25, so 25 can cut 25, so that we have 20 is equal to 10k, and if you divide both sides by 10, k, our k is 10 here in 1, 10 in 22, k is 2. So the expression for F in terms of m1, m2, and d2 is 2 multiplied by m1, m2 over d raised to power 2. That is the expression for F that we're asked to find. Now, this is question 1. Then, in the second case, we are asked to find the distance when the force is 30, m1 is 7.5, m2 is 4 kilograms. Okay, we can go ahead to put in those values now. Now, in this particular case, we are told that the force is 30 newtons. The first mass is 7.5 kilogram. The second mass is 4 kilogram. We have to find the value of the distance between them using this formula. Okay. So if you want to just put in all the values, you know that will give us 30 is equal to 2 multiplied by m1 is 7.5, m2 is 4 over d raised to power 2. Okay. So now this is 30 over 1, and if we just cross multiply the expressions, we have d raised to power 2 is equal to 2 times 7.5 times 4 divided by 30. 2 and 7.5, that is 15. So 15 here 1, 15 in 32. 2 can go in 4, 2 here 1, 2 here 2. That means d raised to power 2 is equal to 2, so that d will be the square root of 2, and the square root of 2, that should be 1.414, okay, root 2 1.414, 1.4142 meters. All right, that's the solution to our problem. In the diagram that we are given, we are to find the value of x. And well, we are told that the diagram is not drawn to scale anyway. Now we need to notice that this is a polygon. And for the polygon of side n is the number of sides, the sum of the interior angles is given by the formula that the sum of the interior angles of the polygon having sides n is 2n minus 4 multiplied by 90 degrees. Okay, just as written on the board. Now, for this particular polygon, we are seeing that we have 5 sides, so n is 5, and then the sum of the interior angles of the polygon will be 2n, 2 multiplied by 5, minus 4, all multiplied by 90 degrees. 2 times 5 is 10, so we have 10 minus 4 multiplied by 90 degrees, and that will be 6 times 90 degrees. 6 times 90 is 540 degrees. Okay, so now meaning that if we add each of the interior angles that were given in values of x and we sum them together, they should add up to 540 degrees, and that's exactly what we are going to do. Okay, so we are going to have this to be x plus 20, the second angle, x plus 40, the third angle, x plus 80, the fourth angle, and x plus 60, the fifth angle. The sum of the 5 of them should give us 540 degrees. We have x in 5 places, so we can add them to give us 5x. Then we can sum up the other numerals. Here we have 20 plus 40 plus 80 plus 60. That will give us 200. So 5x plus 200 is 540 degrees, so that 5x will be 540 minus 200, and that will be 340. Okay, so we have 5s6, 340, and if we divide both sides by 5, the 5 can cut the 5 on the left hand side. 5 in 34, that will be 6. 5 in 40 is 80. So you can just confirm with calculator. 340 over 5, that's 68. So that means that the value of x is 68 degrees. All right. Yes, this is a question on grouped data. Okay, and we are told that the table shows the marks obtained by students in a biology test. Now we are to construct the frequency distribution table using the class interval 0 to 9, 10 to 19, 20 to 29. If you continue, we are going to get 30 to 39, 40 to 49, and so on. So let's go ahead with our first question there. We want to get a frequency distribution table. Okay, so now I'll just do a rough sketch here, and I will advise this is the best way to go about your work. Have the mark, the tally, and the frequency. Then, for example, we have been given the range 0 to 9. We need to find, okay, now we have 9. That's the first 9 we are seeing, and there is no other one. The frequency, therefore, is 1. Okay? Then we have 10 to 19. We are going to be looking for all the places that we have numbers from 10 to 19. Second row, none. Third row, okay, we have 18. Okay, the fifth row we have 15. That's 2 tallies. We have 16. That's another tally. Don't forget to tally your data. It will help you to actually map out what you need to get and not make mistake. You need to be very careful. Now 20 to 29, we are going to look in the first row. We have 1. This is 25. That's 1. We have second row. We have 20. That's 2. Okay. If we still continue, the third row, we have 21. That's 3. Okay. The fourth row, we don't have any. That's all. So the frequency is 3. And the same thing we do for 30 to 39. You can see the way we actually go about doing this. In the first row, there is no 30. In the second row, we have 39. Our tally, that's first one. In the third row, we have 36. That makes it 2. Okay, we also have 32. That makes it 3. In the fourth row, we have 37. That makes it 4. We also have 35. That makes it 5. And in 5, we'll cross over the 4 entries in our tally. Then we'll continue with 6, 34, and that's 6. So, like this, we just continue doing all this. We use the tally as a guide, and then when we're through, we get the frequency. Now, if you are working with your question paper, you need to be careful so that you make sure that you don't miss any of the entries. And as a rule of thumb, you need to check after you are through to confirm that the total frequencies that you got is going to be equal to the total number of data that you have been given. And that's what we are going to be doing now. Okay, so I'm speeding up the video so that you don't just get bored repeating the same thing over and over, just to get the idea of how to do this, and then we can check afterwards. So here now, we want to check. Now, already we are seeing that we have 10 columns and 5 rows. That will be 10 times 5. That's 50. So all the entries, if you add all our frequencies, that should give us 50. So we have 1 plus 3 plus 3 plus 6 plus 8 plus 12 plus 6 plus 3 plus 4 and plus 4. That's 50. So you need to check with this so that you can be on the right track. Now, checking, I know that now I'm on the right track. I can go ahead with the other equation, but I cannot emphasize this enough. Once you miss out on the number of entries, there's no way the question is going to be correct. Your solution will not be correct. But if you have checked and you have confirmed that all the entries are represented, you have your frequency as desired, you can now go to get the other questions done. Like here, we're told to draw a cumulative frequency curve for the distribution. That will be a curve in which we have on the x and the y axis, we have the cumulative frequency, okay, and then we are going to be using the class boundary, and we are going to draw that graph, the cumulative frequency against the upper class boundary. So here, already we have our mark, we have our tally, we have our frequency, but we need the cumulative frequency and we need the upper class boundary. So we get the cumulative frequency by adding sequential entries of the frequencies, just as I'm going to be doing right now. In the first case, we have just 1. In the second case, we have 1 plus 3 is 4. In the third case, that 4 we add to 3 to give 7. In the next case, we have 7 plus 6, 13. Then the next one, 13 plus 8 is 21. The next one, 21 plus 12 is 33. The next one, 33 plus 6 is 39. 39 plus 3 is 42. 42 plus 4 is 46. 46 plus 4 is 50. These are the cumulative frequency data that is needed for us to plot our graph. Then the class boundary. To get the class boundary, take for example the second range of marks, the 10 to 19. What we do is we subtract 0.5 from the first entry and we add 0.5 to the last entry. So normally that class boundary will be 10.5 to 19.5. But for us, what we need for our graph is the upper class boundary. So we are going to be taking the 9.5, 19.5, 29.5 as our upper class boundary. The class boundary is from the lower class boundary to the upper class boundary, but we just need the upper class boundary. So for all of the entries, we just put in the value of the upper class boundary: 9.5, 19.5, 29.5, 39.5, 49.5, and on down to 99.5. These are now our cumulative frequency curve, the whole give, is going to be a graph of the cumulative frequency plotted against the upper class boundary. Okay, so we can go ahead and see what we can do with respect to that. So now we are going to be plotting our cumulative frequency curve by plotting the cumulative frequency on the vertical axis, okay, and the upper class boundary on the horizontal axis. Now we are concerned about what scale do we need to use. Here we are having entries from 1 to 50, so our scale should be able to cater for that. And then the class boundary, we're having 9.5 to 99.5. If we look at the divisions on our graph and we have decided to append in units of 5, we can see 25, 30, 35, 40, 45, 50. That caters for all the data entry that we have. So we can say 2 centimeters, that's the size of each of the tick boxes, should represent 5 units on the vertical axis. Now on the horizontal axis, we don't need to start from 0 so that we can actually get a good view of the dot 5 that are reflecting there. If we just take it in steps of 10, starting from 9.5, here we have 69.5, 79.5, 89.5, and 99.5. You can also see that those incremental values amount to us having all of the data represented on the graph also. So also on the horizontal axis, we can say the 2 centimeters is representing 9.5 units. But you can see at the beginning of the horizontal line, it was notched, meaning that it's not it's not linear at the beginning at that point. We are not starting with 0.9.5. No, we are just starting from 9.5, then increments by 10 units. Okay. So our scale is 2 centimeters represent 5 units on the cumulative frequency axis, and 2 centimeters represent 9.5 max on the upper class boundary axis. So we now need to plot this as appropriate. In the first case, we have 1 and 9.5. Since this is 5, each of the division will just be 1, 1, 1. Okay, up to 5. So this is 1 and this is 9.5. Their point of intersection is being shown with that cross. So we just note it. This is the dot. That's 1 and 9.5. 4 and 19.5. Okay, this is 19.5 and 4 is just before 5. 29.5 and 7. We have 5, 6, 7. You can see this is the reason why actually we use the data value 9.5, 19.5, so that we can just plot them off on the graph. If you have used 10 and 20, 30, you will need to have been looking for, okay, where is 9.5? And that will not give us the exact value. So this is the best way to go about. This is even the standard way that the cumulative frequency curve is plotted. So now we just mark off the subsequent values for cumulative frequency and the upper class boundary. Like here, we now have 69.5 and 39. 39 is just before 40, okay? Then 79.5 and 42. 42 will be 2 steps above 40. 89.5 and 46, just after 45. Then 99.5 and 50. 50 is the last entry. Now, having done this, all we need to do to get our cumulative frequency curve, the OGIF, is to join all the points together. I advise students you can use a French curve or you can use a broomstick. I've also found that to be very useful. But since this is a digital workout, I'm just using my free hand to try as much as possible to make them link together. And this is now our cumulative frequency curve, the OGIF, for the ungrouped data, which we grouped and we have now worked upon. And this is the graph for the data that we are given. Okay, so now we can go ahead to solve for the other questions that we have been asked. We are done with the first and the second question now. We can move ahead with the other questions. Okay, so the other question, we are to use the graph to find the median mark for the students. So this is answer to A, this is answer to B. So C and C1, to be precise, we want to find the median mark. Okay, the median mark in the test. The median will have to be, now the cumulative frequency is 50. the median will have to be half of the total frequency. And that is half of 50, that is 25. So what we need to do to use the graph to find the median is to go to the 25th entry, which is half of 50, and trace it to the graph, okay, just as being shown. And then we trace that down to the class boundary, and the entry that is there is what is going to give us the median mark. Now, looking at this, we have 49.5. The next one, because they are incrementals in 2, will be 51.5, and the next one after that will be 53.5. The mark we are looking for is in between those two, and that will amount to 52.5. So the median mark as obtained from the graph is 52.5 marks. Out of all the marks that are scored by the students in the biology test, the median mark is 52.5 marks. So finally, we are also asked from the question that we are to find the percentage of students. Now notice, this is not marks. We are to find the percentage of students that scored at least 66 marks. Okay? Now, we are told at least 66 marks. So that is giving us the mandate to go to our mark that's on the horizontal line, and we are to find out where 66 is falling. Okay? Now, we've explained the division already. So 66 is coming here on the point being shown in green, and we trace it to the cumulative frequency axis, and then that is at least 66. We know the highest mark that we have is 99.5. So the range that's being shown in green, and it's just being shaded in green, is the range of students that scored at least 66 marks. That means the least is 66, they can score 67, 68, 69, 80, 85, 90, 95, 99. But 66 is the least. So it is this range of students that we are trying to look for. So on the horizontal axis, the shaded area corresponds to the marks that are at least 66. Okay. Then the number of students is going to be reflected on the cumulative frequency axis. That's the frequency range for students that score at least 66. And that will be 50 minus the lower boundary is 38. That is 12. Okay. So that frequency range is 12. We are asked to find the percentage of students that scored at least 66. So that will be 12 over the total student, which is 50 multiplied by 100%. So if you cut, this will amount to 24%. So 24% of the students scored at least 66 marks. And with that, we are done with our question on the cumulative frequency graph.